guys. So today we keep solving our subject physics GRE, and this is the new form. I think it's, let me see. I think this form is the A677. So I personally got 990 at the physics GRE exam. So basically, I got 4 scores. So I would like to share my skill set to solving the physics GRE, and you can basically see how I guess the answer and how I do this. Okay, so let's start. Okay, so basically the first few questions is basically mechanical, some mechanical problems. So the first few is very easy. Okay. Okay, so we start from the first one. Okay, so a rock is run vertically upward with initial speed. Assume that the friction force proportional to, basically you have this one. And also your equation of motion is there some mg minus kv, which is something which is proportional to the velocity. And this is force, and equals to ma. Okay, so acceleration basically is g minus kv over m. So the first one said acceleration of the rock is always equal to g. This is not correct, because it's g minus something. Okay, B, the acceleration of rock is equal to g only at the top of the flight. So at the top of the right means v equals to 0. So at the top of the right, the A acceleration is equal to g. So the answer is B. And C said that the acceleration of the rock is always less than g. Okay, so one might think this is correct. Okay, but you can because it say less than, right? Actually, it should be less or equal than. The speed of rock upon return to its, basically this is not correct, because this will because your kinetic energy will lose something in the friction, so the energy will not conserve if you only consider kinetic energy. The rock can attain terminal speed greater than this is not impossible, because your energy will be dissipated at least by the friction. Okay, so this is B. Okay, so number 2 said a satellite orbit. So maybe we draw our picture. Okay, so this is Earth, and this is satellite. And then astronauts on board perturb the orbit slightly by briefly firing a control. So you start firing something, and then ask you about the following true about the satellite's path. So because it fires a control jet aimed toward the Earth center, so I plot different. It should be here. Then basically when you do this, then your speed start to decrease. So your speed start to decrease. Then this tell you that I should say your because due to a momentum conservation, you will have another extra speed from basically outward. So basically, once you increase this, then you will start to do the eclipse or orbit. So the answer is A. Because we can guess that this term must be something which is smaller. But since you are at the original orbit or original circular orbit, so if we do some small perturbation, then it will change into eclipse orbit, and then not hyperbola or something like this. Because you only have three types. One is ellipse, one is hyperbola, and one is circle. Right, but there's no way that you still forms a circle, because you already a circle, and you just perturb some velocity. So the answer is A. So sometimes in GRE that you would need to somehow guess the answer. Okay, so problem 3. Sorry, I didn't catch the full answer. There's a blue light and the transparent material has a relative permittivity of 2.1 and ask about basically the speed. Okay, and the phase velocity of the blue light is about the median. Okay, so there's nothing special. The velocity just this. In any material is like this. So, and this is the light. So basically, you have permittivity 2.1. So we just change this. So that means your epsilon is 2.1 epsilon naught. So this V is just C over square root of 2.1. So the answer is, this answer is, let me see which one. The answer is D. The answer is D. Okay, that's it. This question is old question, which I have already seen few times. Okay, so this one. So basically, ask you about a wave. So the amplitude is A, and the velocity is positive, although this is negative, but you can see when x increases by lambda and t decreases by t, then the wave is from left to right. And the period is basically, the period means that how much it takes to let x to let. So the period means that period means the time goes to t plus something. Then the wave should be the same. So you see, it should be 2 pi t over t to be alpha to be 2 pi. So alpha is t. So the period is t, and the speed is what? Speed means that the wavelength times the frequency, or the wavelength divided by period. So should be lambda divided by large t, and the lambda is the wavelength. So the answer is E. The answer is E. Okay. Okay, and the two small sphere of booty, basically A or B, of mass and respectively Hamill clothing, and the one sphere A. So they raise to H0 above, and the up shown above, and then release. So basically release, and the sphere A coincident with sphere B, and then stick together. So stick together means that the momentum is conserved. Momentum conserved, and then they stay together. So basically, first we know that the mgh0 will be the velocity when A hit to B. So A hit, this is V naught, this is B, and this is M, this is 3M. So after use momentum conservation, they stay together with the final velocity. So final velocity is 1 over V naught, 1 over 4 is V naught. So since we know that the height is proportional to velocity squares, so height will proportional to velocity squared. So the answer should be 1 over 16. 1 over 16. So the answer is A. Well, that's A. Okay. Okay. I think it's enough for today, and I maybe solve the 5 or 10 question in a video, and because I think it's enough for a video, just contains like 5 or 10 questions. So I will see you guys in the next time. Be sure to subscribe to my channel. Thanks.